All right, good morning, everybody. So, picking up from where we left off in last class, we were talking about constructors, and so here's the constructor for the point 2 class. So remember, our point 2 class represents two-dimensional points having real coordinates. So we've got an x and a y field representing our coordinates. Right? The type is double, so reflecting the fact that this is supposed to be a object having real coordinates. The fields are marked as being private, indicating that no one outside the class can access the fields x and y directly by name. Our constructor, well, our no argument constructor is down here. So remember, the name of the the name of the constructor is always the name of the class, so that has to match that. Right? It's the no argument constructor, so we have the empty round brackets, no parameters in between. And the constructor is marked public, indicating anybody that can see the class can also see the constructor. We've decided that our constructor should set the coordinates of the point to 0 and 0. So inside the constructor, we write either x equals 0 and y equals 0, or in this case, I've written this dot x equals 0 and this dot y equals 0. Inside a constructor or a method, a non-static method, the keyword this refers to the object that in a constructor, it refers to the object that's being initialized. Inside of a method, it refers to the object that was used to call the method. Right. So the next slide actually shows you exactly what happens when you someone calls a constructor. Yes?
So what if we don't use this in front of x?
In this particular case, if you don't use this, there's no problem. So let me just switch over to Eclipse and show you. So this is the full point 2 class. I'm just going to show you the constructor. I guess I should fix that too, because we made some edits to it in the last class. All right, so if you don't write the keyword this, in Java, everything's fine. Well, so in this particular case, everything is fine. So if you don't write the keyword this in front of the x, the compiler is smart enough to figure out that you mean the field x right here. And so if you just write y, it's smart enough to know, well, you mean the field y. You can Eclipse highlighting it. So when I click on the x, you can see that, Eclipse highlights the field x here. So Eclipse is trying to tell you, when you write x equals 0, you mean the field x in this case. A little bit, so I guess in the next lecture, I think, I'm going to show you an example where you have to write this. And I might as well just show it to you right now. And so we're going to write another constructor a little bit later on. Sorry, just let me fix the indenting. Okay, so probably in the next lecture, we're going to create another constructor, and this constructor lets the user make a new point and set the coordinates of the point to their own value of x and y. Now notice the problem here. I've got a parameter called x and I've got a parameter called y. So inside the constructor, if I try to set the value of the fields, I'm going to end up writing something like that. If I didn't know about the keyword this, you would say, well, what happens when I write x equals x? What exactly does that do? So it turns out inside of a method, inside the constructor, if you have a parameter, then when you write the name of when you write down a name, it matches the name of the parameter before it matches the name of a field. So here, when you write y equals y, that does nothing, right? It sets the value of the parameter y to the value of the parameter y. So it does nothing. In this case, you want to set the value of the field x to x. So here you must write this x, and here you must write this dot y. Right? Yes?
So basically, this indicates that we're calling for fields.
So to be completely clear, this is a reference to the object that is currently being initialized. So this is like a name of a variable, right? But the variable refers to the object that's being initialized at this point in time. And this slide hopefully makes everything clear. So when you make a new point object using that constructor, right? So when you write that one line of code, a surprising amount of stuff actually happens underneath the hood. So we have a variable called p. So somewhere in memory, we get a variable called p showing up. Right? Now, on the right-hand side, we've got new point 2. So, right, 1, p gets created somewhere in memory. Right? Step 2, new. The new operator runs or does whatever it needs to do. So new is the thing that allocates memory for a point to object, right? So remember, it's new that actually makes the object. How does it make the object? It finds the class point2 and makes a copy of it, right? So our point2 class has an x and a y field, so we get a copy of the class, right? And there's our newly created point2 object. Okay, so what does new do next? So once it makes the object, it calls the constructor. So the point2 constructor gets called. When new calls the constructor, it passes in the value of the object that was just made to the constructor. So when the constructor starts running, so here's our constructor running somewhere in memory, right? It has its own, you can think of it as being a variable called this, right? And this has the value of the address of the object that was just created by new, right? The constructor needs the address because it needs to know on the next line, when you write x equals 0, what x do you mean, right? And so in this case, it's this dot x equals 0, so you follow this to the object, you look at its x value, and you set it to 0. Right? Similarly, we write this dot y equals 0, so in the constructor, it follows the this reference up to this object up here, finds its field called y, and sets it to 0, like that. Right? And now finally the constructor's done. So once the constructor's done, new can finish doing whatever it needs to do, and new returns the address of the newly constructed object. So in other words, it returns the address 700 back to the caller. So all of that becomes the address 600, right? And the value of p is now a reference to the newly created and initialized point2 object. Right? So that one little line of code causes a whole sequence of events to occur. Right? Remember, your constructor here could be arbitrarily complicated. So calling a constructor could result in a whole lot of work being done, depending on how complex this constructor actually is. All right, any questions about what I just, about what actually happens when you call a constructor? Okay, so we're gonna do for the next class. So remember, our counter class is just this object from 0 to integer max value in increments of 1. Right? We don't have a constructor in it yet, so let's put in a no argument constructor. In this case, it seems to make sense that if you make a counter, then the default state of the counter ought to be 0, right? So this kind of makes sense. So here's our counter class. Right? There's our field that represents the value of the counter. Here's our constructor. What does the constructor do? It sets the value of its fields, right? So we set value to 0. Again, you can just write value equals 0 here and everything would be fine, right? But to be explicit, I will always write this dot value to indicate that we're accessing the field of the class. Okay, so what happens when you run the constructor, right? Well, the exact same sequence of events occurs, right? Somewhere in memory, C gets created, so I need a variable C. So we get memory for C. Right. New allocates memory for the counter object. So we have new, right? And we make a new counter. So somewhere in memory, a counter object appears. Right? Every counter has its own field called value. New then calls the counter no argument constructor. Right? The constructor runs somewhere in memory, so there it is. Right? It gets the value of the newly created object. Right? And it stores that in the parameter, this variable. So I'm calling it a variable. It's not really a variable. You're not allowed to change the value of, actually I should check if you can do that. I don't think you can change the value of this. No, you can't change the value of this. Never mind, I'm being a dummy. You can't do that. Oh, sorry. I think I have a stuck key somewhere, sorry. Okay, so I don't think you can write this equals new. Whoops, sorry. Is it happy with this? I don't think it's happy with this, is it? No, so you can't assign this, right? So I'm calling it a variable. This isn't actually a variable. It sort of behaves like one, except you do it. But conceptually, this is just a variable storing the address of the newly created object. Right? Inside the constructor, we write this dot value equals 0. So follow this to the object. right? Set the value to 0, right? And now the constructor finish is running, new finish is running, and returns the address of the constructed object back to the caller. And so C gets the value 550A in this case. Right? It's always the same thing when a constructor runs, right? Variable gets created, object gets created, constructor runs, constructor sets the value of the fields to the object. Okay, so our stopwatch, just quickly to remind you, remember the stopwatch is this, represents a physical stopwatch where it has a start and a stop button, right? And remember that we keep track of the start time, the stop time, and whether or not the watch is running. So it's going to be all the same sort of thing, right? So here's our stopwatch class. We've got 3 fields. There's our constructor, right? What should we set the start and stop time to for a newly created stopwatch? Well, 0 seems to make sense, right? So we set both of those to 0. For a newly created stopwatch, it probably makes sense to have the watch not be running, so we set is running to false. Right? I guess just as to point out, the start and stop time are both have long values. The reason they have long values is because we're going to call a method that returns the time as a long value. And we're going to store those here. So if you want to write down 0 as a long, you can write down 0L in this case. So that's what the L is there for if you're wondering why it's there. Okay, so we now have one constructor in all of our classes. So now that we've got a constructor, it would be nice if we can make our objects actually do something, right? So we can now set them to a default value. So now let's make the objects actually have some sort of behavior or some sort of ability to calculate something. And that's what methods are for. Right? So methods perform some sort of calculation. Right? Now remember, we implemented a bunch of static methods in the first 2 or 3 weeks of class. Right? So when you use a static method, you always use the name of the class to call the method. Most methods aren't static. So most methods are non-static. Right? Just like most classes are meant to be used to create objects. Right? So a non-static method is a method that's not marked static. To call the non-static method, you need an object reference to, right? And the non-static method is able to use any field belonging to the object, right? And so that's the whole point of, that is the entire point of having objects, right? Every object gets its own state, but gets its own fields, right? And that means individual objects can calculate stuff using their own data. So all of our points have their own x and y coordinates, and so we can now write a bunch of non-static methods that operate on the coordinates of the point. So for example, here's set. Right? Set lets us set the coordinates of a already created point. Right? So it's so notice what it looks like. It looks like public, so anybody can use the method as long as they can see the class. This one's a bit unusual, so it returns a reference to a point to object. Right? Its name is called set, and it takes in 2 values, new x and new y. Right? If you look at the comment up here, it says it sets the x and y coordinates of the point. It should say of this point to the specified value. Right? So in other words, we want to write something like x equals new x, or this x equals new x, right? And y equals new y, or this y equals new y. Notice that this particular method returns this. I'll come back to that point in just a second. Right? So we can also provide methods that let the client change just the x coordinate of the point. So this one changes both x and y. Right? There is a method that changes the x coordinate of the point. So it changes x to new x. So you just write this x equals new x inside the method. A common mistake here made by very new programmers is to flip this around. So it's not unusual to see new x equals this dot x. That's not what you want to write. Right? When you write new x equals this dot x, you're changing the value of the parameter to the current x coordinate of the point. That's not what you want to do. You want to set the current coordinate of the point to new x. So it's this x equals new x. Again, I'll explain the return this shortly. Right? And finally, you can do the exact same thing for the y coordinate. Right? Here's another method called y, changes the y coordinate to new y. Right? All 3 methods are more or less the same. Right? Why did I do this way? Where is, okay. I'm not sure why I did it this way. Anyway, so methods that change the state of an object are often called mutator methods, right? They mutate or change the state of an object. So set x that takes in a double value and y that takes in a double value are all examples of mutator methods. There's also accessor methods. So accessor methods are methods that return information about an object, but they don't change the state of the object. I probably should have started with this. I'm not sure why I flipped them around. Anyway, so if someone's working with a point, there's a pretty good chance that you're going to want to know at some point what is the x and y coordinate of this point, right? So they have a point, they make a point, they perform some calculation with the point, and then eventually they're going to want to know, okay, so where is this point? Right? So we want to provide methods that return the x and y coordinate of a point as well. So here's a method. It's just called x, right? No parameters here. And this version of the method returns the current x coordinate of a point, right? So in other words, it returns the value of the field x, right? And you do the same thing for y, right? Names y, it returns a double value, so it returns the coordinate stored in this dot y. Okay, so to explain the method, thoroughly explain how to write a method, you need to know what are the things that make up a method. So the first line, where you start to declare your method, some people refer to it as the method header, right? So in Python, you write def, some function name, right, and then the parameters for the function. In Java, it's a little bit different. So in Java, you have these access modifiers. You also have static, which is considered a modifier. So if you have any modifiers, they go first. Java requires you to specify the return type of a method. Right? Python, you never specify the return type of a method. Right? Java, you must specify it, so the return type goes next. Right? Then the name of the method comes next. Then you've got the round brackets. And then you have the list of parameters inside the round brackets. Number 5, we never look at in this course. You might see stuff online, though, if you are searching for Java-related questions. After the parameter list, so after the closing round bracket, you might see something called a throws clause. I never show you exactly what this is in this course. If you're curious about this, you just come ask me about this in office. All right, so the modifiers come first. So for our set method, the only modifier that we have is the keyword public. Right. The next part is, after your modifier, your return type. So here, set returns a reference to a point2 object. The next part is the name of the method. Right. So here our method's called set. Then you have a pair of brackets, and inside the round brackets, you have a comma-separated list of parameters. Right. Every parameter must have a type. Right? And the easiest way to, I guess the correct way to think about the list of parameters is that these are variables that belong to the method. I believe it's number 9, 10, 11, 12, I think, 12 or 13, I'm not sure. Okay, so that thing inside the parameter list, it's the list of types and names separated by commas. So the names inside the parameter list must be unique, right? So I can't write double x, that doesn't make sense, right? You can have another method that writes double x, double y, that's fine, right? But inside this method, in its parameter list, the names must be unique. So the signature of a method consists of the name and the types in the parameter list. So the signature for set is set double double. Now, the reason the signature is important in Java is that inside of a class, the signatures must be unique. Right? So inside the class point2, I'm allowed to have a method called set that takes in 2 doubles. I can add in another method called set that takes in other information instead. Right? So I can have a method called set that takes in, say, 2 floats, or a method called set that takes in 2 ints, or a method called set that takes in a string, or something like that. Right? And that would all be fine. So the names of the methods don't have to be unique, but the signatures must be unique. And so if you want to understand signatures, I guess for more examples of signatures, here are a bunch of methods in string, right? So we've got two uppercase. What's the signature of two uppercase? Well, it's the name of the method plus its parameter types, so it's just two uppercase. Right? Here's car at. Its signature is simply its name, so car at, and its types of in the parameter list, so int. Index of has the signature index of, and then string, and then int. So index of, string, int. And then finally, get cars has the signature get cars, int, array of car, and int. Right? And of course, these all came from the string class, so notice that none of these are repeated, right? So they're all unique. There is another index of method, right? So there's an index of method that takes in a car, right? So there would be another signature inside the class, index of round brackets car. So once again, signatures in a class must be unique. So if I wanted to, I could have a method called set that sets just the x coordinate. Presumably, this sets the x coordinate to x and sets the y coordinate to 0, right? So that's fine. We have set double. Our previous version of set had set double double. There's no way for you to put in another set method that changes just the y coordinate because that conflicts with the other set method on the slide. Right? These two have the same signature. They both can't exist at the same time in the same class. Right? That's why there's a set, an x, and a y, because I can't put in set, set, and set. Okay, so if you have two methods with the same name in the same class, those methods are said to be overloaded. Right? So that's the term overloaded. You have to be careful with this term because there's another term called overridden, which means something completely different, right? So it's important to be clear, overloaded means multiple methods, same name in the same class. So for example, inside the point2 class, you might, if you're working with, point2 is made for geometry, so it's often the case you want to compute the distance between 2 points. So the distance2 method lets you compute the distance between 2 points, right? So p distance 2, 1, 1 lets you calculate the distance between the point 1, 1 and your point P. Right? So if someone specifies the points with two floats, that's fine. Right? Or they can specify it with two doubles, that's also fine. Right? The signature of these two methods are different because their types are different. Right? If you're working with points, it kind of makes sense to have add a method that takes in another point. So you can compute the distance between a point and some other point P. So to use that method, you would write something like double distance equals q dot distance 2p. Right, where q and p are already existing points. Yes?
Why don't we just put it all into one?
You could. So you could put it into one method. So if you picked just one of those, right? So let's pick the last one, right? That forces someone to make a point2 object to call the method. So if someone's using your class, but they have their x and y coordinates stored in an array or something else, they now have to make a point2 object every time just to call your method. So in this particular case, these all exist for the convenience of the end user. That's the only reason they're here. Yeah. Any other questions? Okay, so signatures must be unique. Every method in Java must specify what the return type is. If the method returns nothing, then you must specify the word void. Right? And the return type goes immediately before the name. So public double x indicates that the method x returns a double. I'm looking for an example that returns void. So the main method of a class, public static void main, returns has no return type, no return value. Right? So you'd use void here if the method returns no value. Okay, methods common to all classes. And so I think in an earlier lecture I told you that in Java all reference types have more than one type. There is an exception to that rule. The exception to that rule is the type called big O object. And so in the Java language, in the package java.lang, there is this class called big O object. Big O object has exactly one type. Its type is big O object. Every other reference type in Java also has the type big O object. Right? And so what we say is that every class in Java is actually what's called a child class of big O object. All that means, for the time being, is that every class has methods that it gets from big O object. So if you look inside the object class documentation, you'll see it has, I don't remember how many methods now. Oh, this has 11. I'm not sure if that's true for the most recent version of Java. But anyway, it's probably 11. They probably wouldn't change this class. So if you look inside that class, you'll see there's a bunch of methods. 3 of them are of particular importance to us. There's a method called toString, there's a method called equals, and there's a method called hashcode. Equals we've seen before, right? If you want to test if 2 strings are equal, you always use the equals method, right? Turns out if you want to test if 2.2 objects are equal, we're going to use the equals method. If you want to test if 2 lists are equal, you use the equals method. All objects in Java have an equals method. Right? All objects in Java also have toString. ToString is what lets println print stuff out. So if I wrote system.out.println p, where p is some point, it would work for our particular class. Right? Hashcode we'll talk about in detail a little bit later on. And so when you're creating a class, it's often useful, especially a value class like point2, it's often useful to be able to print out your objects in a way that's readable to a human, right? If only for debugging purposes, right? It's often useful for other purposes, but even to just debug your program, it's often useful to print stuff out. And so if you want to print out a point, it turns out you should redefine how toString works, right? So in other words, if I want to print out a point p, so a point whose coordinates are -1 and 1.5, right? It would be nice if it printed out something that looks like that. You could choose something else, right? Braces instead of round brackets, square brackets instead of brackets, whatever you want. It's up to you, right? But it would be nice if you could print out a point that looks something like that. Right? So how do you do it? So it turns out you replace the method called toString, right? So inside of our class, we put in a new method, right? When you replace toString, you must write the header exactly the way it's shown here, right? So it's always public, it always returns a big S string, its name is always toString, right? There's never any parameters to that. Okay. I'll explain that in just a second. Right? So inside toString, I want to generate a string that looks like this. So to generate that string, I need an opening round bracket. Then I need the x coordinate of the point, then a comma, then a space, then the y coordinate of the point, then the closing round bracket. Right? And so in Java, we can compute all of that using string concatenation. Right? So I want the opening round bracket, right? Followed by the x coordinate of the point, followed by a comma and a space, followed by the y coordinate of the point, followed by the closing round bracket. That produces a new string, right, which we can then return back to the caller, because that's what this returns. Right. Okay, so what is this @override tag? Do you need it? So the answer is no, you don't need it. It doesn't have to be here. Okay, so when you see something that starts with in Java, that's called an annotation. The annotation is simply information that something else can use to get information about the thing that you're annotating. So the @override tag means it tells the compiler that we're trying to redefine this method called toString. Right? So we're trying to redefine this method called toString. So the compiler checks, are we actually redefining a method that can be redefined? Right? How does it do that? It goes and looks in the object class, right? And it looks for a method that matches that exactly. Right? So if you go and look in the object class, which we can look at the documentation for, So Java, Java lang object. Not that one, here. Okay, so if you look at the documentation for the class object, right here, right, we will find, we will find a public method called toString, right? It has no modifiers, it returns a string, it has no parameters, right? So if there's a method inside of object that you want to replace, you can, right? As long as it's not marked final, right? If it's marked final, you can't replace that method. ToString is not marked final, so we can replace this method. How do you replace the method? You override the method, right? So remember, like 10 minutes ago, I told you what overloaded means, and now I'm telling you what override means, right? The two things mean something very different, right? Overload means you've got multiple methods with the same name. Override means you're replacing the definition of an existing method, right? So if you write the @override tag in front of a method, the compiler will check, does this method already exist? In this case, does it already exist in object, right? If the exact same method already exists in object, the compiler's happy, and it goes on its merry way. If you change something here, the compiler will complain. So back we go here, and hopefully there's a toString in here somewhere. There is. It's much more complicated than the one I just showed you, but that's fine. Okay, so there's my redefinition of toString. So what happens if I accidentally write the name in wrong? Right, so instead of capitalizing the S, if I accidentally turn it into a lowercase s, right, and the override tag is here, or override annotation is here, the compiler will flag this as an error, right? So notice that Eclipse says, the method toString of type .2 must override or implement a supertype method. That's the compiler's way of telling you the method in object named toString is not called to_s_string, right? It's called to uppercase string, right? What happens if you strike the return type? So now I'm saying it returns nothing. Again, the compiler will complain, right? It says the return type is incompatible with object toString. Right? And what happens if I change public to something else? So what if I make it private? Right? Again, hover over the error. It says you cannot reduce the visibility of an inherited method from object. Right? And so the override tag here, it's nothing other than an aid to the programmer. Right? By adding the @override tag, you're asking the compiler to check for you, does this method actually exist in object? If it doesn't, the compiler will warn you, and it'll tell you this is in fact not an override. Why is this important? So remember, you can have multiple methods with the same name, right? So for example, I can put in a toString method that takes in, I don't know, .2 object. Right? Okay, if I get rid of the @override annotation, it's fine, right? This method can happily coexist inside of the .2 class with the other toString method, right? The other toString method has no parameters, so the overload is fine, right? So if you incorrectly write this and try to print out a point, so let me try to print out a point down here. p.toString, like that, and run it, sure, right? You get something that does not look like the string output for a point, right? You get this gibberish here instead, right? The gibberish actually does mean something, but it's not useful, right? And so you ask yourself, well, what went wrong? And the answer is, right, you didn't call that version of toString. Right? We called the object version of toString, right? And it turns out the object version of toString spits out some gibberish like this, right? And so had we written in @override here, right? This would help us. That would help us determine what our problem is, right? Problem is, we're not actually replacing the method that exists. We're defining our own new method. Right? When you fix the method, everybody's happy. Right? Now you get the point that you want. When you go to print out a point, you actually don't have to call toString yourself. So if you use print or println, and you pass in an object reference, the method will automatically call toString for you. And so that also works just fine. Right? So you don't have to manually call toString if you want to print something out using print or println. Just pass in the object reference and it'll call it for you. Okay. Any questions so far? All right. So by providing toString to users of the class, that's what clients means, by the way. So wherever you see clients, just replace users of the class. Right? You can now easily print out a point. So for example, right, make a point, change its coordinates, print the point. I don't tell you there. Right? Again, you can just write p here. You don't have to write p.toString. Oh, I forgot to tell you something. Sorry. I said I would explain the funny in set in x and y. Sorry. Okay, let's go back and look at set and x and y. Okay, so here's x. So x returns a reference to a point to object. Right? When you look at the return statement here, it's returning this. Right? So remember what this means inside of a method. Right? Inside of a method, this was the object used to call the point. So if I write p.x and then one more, right? Inside the method called x, right? So inside public point to x double. So inside this method, this is just p, right? So when you call a method, when you call a non-static method, inside the method itself, the keyword this refers to the object that was used to call the method, right? And so x knows that when you write p.x, you want to change the x coordinate of p, right? Because this is equal to p method. Right. So what is the purpose of returning a reference to the point in this case? Right? So why did I return this? The answer is it lets you, because it's returning this, it lets you call another method with the return type, with the return value. So here's an example. Here's my point2 object, right? I'm going to call the accessor method called x to get the x coordinate of the point. I'm going to print it out. Right. So let's run that. Okay, I'm going to run that. So there's the first line of output, right? We made a point, its x coordinate is 0. I'm then going to call the mutator method called x, right? Change the coordinates of p, change the x coordinate of p to 5.5. And then I'm going to print out x again. Right? So now x is 5.5, so that's good. Set does what we want it to do. Okay, here's also p. Right? I'm going to call x again. Right? This time I'm going to change the coordinate to 10. Remember, this version this version of x returns a reference to a point. So I can make a variable of type point2, right, and store the return value in that variable. Right? So I'm calling that also p. I'm then going to ask also p, what is your x coordinate? Right? And you're going to discover that's 10. Right? So in this case, also p and p, they both refer to the same object. Right? Because p.x returns this. In other words, it returns p. Right? So also p and p, exact same object. Right? Now notice what happened here, right? So I used the name OP to call a method, right? Also P is a reference to a point. Okay, so what's going on here? So again, I'm going to call x using the object p, right? Now remember, x returns a reference to a point, right? And in fact, it returns p in this case, right? So everything that I've got highlighted there ends up being equal to p. So you can now use that object to call another method, right? And so I can chain a bunch of method calls in this case. Because this returns a reference to the point itself, right? I can now chain a bunch of method calls. So here I can write p.x.y, right? And that changes both the x and the y coordinate in one line of code. You could also use set here, right? If set didn't exist, you could write this particular line of code to change both the x and y coordinates at the same time. All right? And this turns out to be handy when you start to do mathematics, if you start to do some arithmetic with points. So if you start to add them and subtract them, divide them, and so on and so forth, often you have a mathematical expression where you want to do a bunch of different things, right? If you return a reference to the point that's being changed or that's being changed every time, you can just chain all of the method calls together instead of having to write them out on separate lines, right? So in other words, I can write this, right, instead of having to write this every time, right? And so again, this is the way here is for convenience of the end user, right? It lets them more easily write multiple methods, use the same object to call multiple methods on the same line of code, right? And so that's why I returned this from that particular method. You don't normally see that in these types of courses, but it turns out to be a handy thing to have. All right, so let's talk about the counter, and then we'll call it quits for the week. So inside the counter class, we would like to add some methods. Right? So if someone is using a counter object, they're counting something. So at some point, they're going to want to get the value of the counter. So we need to provide a method to do that. Right? Again, if someone's using a counter, they're trying to count stuff, so they're going to want to make the counter go up by 1. Right? So we want a method that advances the value of the counter. Right? And, well, we know how to make a string out of an object, so it might be nice if we could make a string out of a counter too. Right? Okay, so there's our constructor. How do I get the value out of a counter? Well, I make a method called value, right? Or get value or something like that. Right? It returns an int because our value is an int. Right? And all you do is return this dot value, and away you go. You can also write return value here. That would be fine in this case. What about advance? So remember, this counter counts from 0 up to integer max value. Also remember from a couple of weeks ago now, you can't go past integer max value. So you have to ask yourself the question, what happens if we try to count past integer max value? Right? And so you have some choices here. The choice I've decided to make here is that the value wraps around back to 0. Right? And so we need to put some logic into our code to ensure that the value goes back to 0 when we go past integer max value. Right? And so the correct way to do this, right, is to look at the current value of the counter, right, and check to make sure that it's not max value. Right? A common mistake here is that students will write something like if this value is greater than integer max value. That doesn't make any sense. Right? The largest value for an int is integer max value. Right? It cannot be possible. It's no way for it to be larger than integer max value. Right? Or they'll write if this dot value plus 1 is greater than integer max value. It doesn't make sense. Right? So here you want to check to make sure, is the value not already the largest value? If it is, you can safely add 1 to it. Right? If it isn't, we need to make it go back to 0. So you just write this dot value equals 0. Right, so be careful when you're comparing stuff to integer max value or integer min value. An int is never greater than max value. It's never less than min value. Right, and finally, toString. So when you implement toString, you get to pick what does the resulting string look like. Right, you can make it look whatever you want. You can make it look however you want. Right, so here I'm going to write down the word count with a colon with a space followed by the value. Right? If you wanted to, you could write square brackets in the value or braces in the value or something else. Right? It's up to you. In this particular case, that's the string I decided to return. Right? And that's it. Again, override here, just to play it safe, right? When you override toString, it's always public string toString written the way it's shown on the slide. All right, any questions about today's lecture? All right, so if not, I guess we'll wrap that up for the week, and I'll see you next week. The next assignment comes out sometime this weekend. Hopefully today, but it will come out this weekend.